Yeah, the rotation is what I like to learn from different people. We are just not waiting on each other for the next 3 months. Yeah. All right, folks. I think I need to ring the bell. Guys, come back from the break room. We love doing that, right? That's it? We love doing that, right? I can see that. Yes. All right, guys. So, welcome back. Are you seeing my screen? I hope. We are going to do two things now before lunch. Lunch will be here shortly in 5 minutes, right? So, and I know after that your attention will be elsewhere. So let me be quick and brief. First, I'd like to do a very quick review of what we talked about last time. You remember that we talked about semantic search. We have been reviewing it many, many times. We saw the examples. If you looked at the examples, you would agree that it is most impressive, right? Today, it might not look, 2023 people have gotten used to it. But if you ask yourself, why is it that, for example, Google search always did much better, understood you much better, compared to any corporate search that you had for documents internally? Do you guys have the answer to that? The internal search was keyword based and? Yeah, so Google has a lot more AI going for it. Right? So the differentiator is AI. And if you want to look for a very concrete way in which AI has changed the world, I believe the first lab should have convinced you of that. The world before AI was the normal search. If you go back and look at it, what it does is, we took a sentence, let's say, a simple sentence, and this is a very quick recap, a friendship with animals. What are the keywords you can extract from it? Friendship and animals. We took a very simple corpus of about 15 documents, and we searched for it, and the search results it came out with, look at your search result 1. It said, and I'll just repeat it for those of you who are new, you search in the documents for a friendship with animals, and the first paragraph or the text, and remember the meaning of sentence in this world is anything you call a sentence. A paragraph is a sentence. A document is a sentence. A sentence is a sentence. A word is a sentence. Right? It's your choice. So grammarians be damned. Sort of the thing. Okay, golden retrievers are not bred to be guard dogs. And considering the size of their hearts and their irrepressible joy and life, they are less likely to bite than to bark, less likely to bark than to lick a hand in greeting. In spite of their size, they think they are lap dogs. And in spite of being dogs, they think they are also human, and nearly every human they meet is judged to have the potential to be a boon companion who might at any moment cry, let's go, and lead them on to a great adventure. Whosoever wrote this, what can you tell about the author? The author has a deep feeling for dogs, isn't it? For animals. And see, what did you search for? Is the word either friendship or animals present in the text? It's not, right? And that is magic. That is the evidence that, and I deliberately picked this in the corpus. I hid this in the corpus to see, 1 second, I'll take questions in a moment. I deliberately hid this in the corpus so that it could find the feeling that you realize that you're not searching for a thing. I'm not searching for the green car. I'm searching for an emotion. And that it found a passage of text that expresses that emotion. And that's the power of semantic search, AI search. Right? One more thing. Let's look at the second search result. It said, if you're lucky, a golden retriever will come into your life, steal your heart, and change everything. Whoever wrote it again, you can see what emotions they have. It is the third search result which has any keyword at all. It says, if a man aspires towards a righteous life, his first act of abstinence is from injury to animals. I believe it's Mark Twain who wrote this. I'm not sure. So the last one has animals. Right? The first two don't have it. And that's the power of AI search, guys. That's what changes the world. So you have to ask yourself, even today, 99% of the companies internally are using keyword search. Why? Why? For heaven's sake, why? Right? This is 2024 now. Right? This paper was published in 2018. In AI's history, we are talking about this paper being published in ancient times, and still people haven't adopted it. Right? You have a question.
No, I was going to point that there was one input with word animal, but it
The
understood the context, but it shows the other ones.
The other ones first, exactly. And that's magic, guys. The next part is you don't even ask using words. So no keywords at all. You give it look at it, you give it a picture. See, remember, human beings communicate in many ways. We speak in terms of pictures. We speak with words, right? We speak with videos and so forth. These are all expressions of mediums of communication. So if you think of an image as a visual language and therefore a language, therefore you expect a language model to understand it. How it does it is a context for a subsequent, actually the paper is the VIT paper. We'll go over this foundational research paper soon. But notice I gave it a picture of a golden retriever. By the way, how many of you own golden retriever and agree with this sentiment?
I agree with the sentiment.
Okay.
We used to have a lab at one time.
Yeah, I used to have a, but you agree with that, isn't it? Yes, I have a golden. So as this passage says, I'm a lucky man. So you take this golden retriever. Now, what do you notice about this dog? It's a furry dog, isn't it? You search for it and you give it some text to find out. And what it does, obviously, this is a toy example, but look at the search results. It says it found the text, golden retrievers are little children. It pretty much knows it's a golden retriever. Isn't it amazing? And then it also knows that golden retrievers are furry animals, furry dogs. Yeah.
So now trying to understand the image of golden retriever to the tuples you were showing of T1, S1 and so. So golden retriever is S1 and the similar text is a furry animal.
No. So that technology is deeper. That is like, how do you take what you could do with text and now elevate it to the level of any visual, any medium? That itself is it's a milestone paper called CLIP. And that reminds me, on your, you may have noticed that on your portal now, there is actually a section which is called, if you go there, I hope it goes there pretty soon. Do you see a section called Foundational Papers? Right? From today onwards, we will start reading the foundational research papers. I will explain it to you. We'll put quizzes there for you to self-assess and so on and so forth. One of the foundational papers, if you want to learn how it is done, is a paper called CLIP. Right? We will cover it next time, or maybe today itself will cover it if you guys are curious.
So Asif, I have a question for you. So I was looking through the document that you gave for the project, right? And I'm trying to think about that.
Yes.
In Oracle, we have the concept of accounts, contacts, opportunity, and mostly we do the Elasticsearch. So what is I'm just saying, if I'm being the part of the product strategy, what is the use case to implement the semantic based search or combine the semantic with the index based search? Can you just give some idea, or it's not required in this case?
You can mix the two up. No, you should. In today's world, not to use semantic search is a criminal offense. You should be given a ticket. Right? Seriously. Or you should do hybrid search. In other words, use the best of keyword search and semantic search. In your particular case, the opportunities, etc., I can explain to you in detail later on why it is relevant, but because that context is not accessible to everybody here, let's take it offline.
Okay, all right.
But the simple answer is you must be using.
Okay.
So here, what you're showing the golden retriever, the image.
Yes.
It's a function of the model that we use, that CLIP, VITB.
And I'll explain the architecture. It just adds to this idea.
It matches the image and the text to the same vector.
Same vector space, exactly.
It is converting the entire image into a vector.
into a vector, meaningful vector,
Comparing the vector from the text. to the
and
vector
comparing the
generated
vector
from
to the text. Exactly. And today we have gone far. We can embed sound to a vector in the same space as text. We can embed video frames to a vector. So the next evolution, and you'll come to it if you want a preview. There are landmark papers. One of them is SAM, segment anything model, and so on and so forth, and embedding of anything. So you will do all of that, guys. You'll do all of that. Yeah. So this bootcamp is the most exciting. I mean, I'm biased, of course, but if it was being offered, I would have registered. Right? But then, of course, I picked my favorite topics to teach you guys. Whatever I'm excited about, I've thrown into it. Right?
So
Now you can do the opposite.
so
Look
that
here. One second, guys, before questions. Let me finish it. Let me finish it, and I'll take some questions. So the opposite also is true. See, you could give it a query. You can query into images because you have the same embedding, joint embedding space between text and images. What can you do? It's multimodal query. You can say, I don't know, to love a dog. As you can see, I'm very fond of dogs. To love a dog. And look at this picture. Can you see that this is not just a picture of dogs, right? But it's a picture of emotion in action. Love in action, isn't it? When you look at this picture, what does it convey to you? Yeah, the joy, the happiness of holding a dog, loving a dog. Yeah, whole questions in your mind. What about this? Right. Yeah, look at this. To love a dog. Is it all to love a dog? Right? This is it. Look at this. Don't you wish you had become a little puppy?
That brings to your social and cultural stuff, right?
Yes, a very good question, actually. Somebody in the audience is asking, doesn't it bring about the context of social understanding? Yes, because when it was embedded, as you will learn in the algorithm, the social meaning that people gave, the machine learned. So these language models are a cultural artifact. It's a very good way of thinking of these language models are very intelligent cultural artifacts. They mirror our culture and our civilization, always. They are not at divergence with it. They completely mirror it. Look at this. And then the next query I gave is house near a lake. See, when you give this to a traditional search engine, it may come up with lots of text about houses and a lot of text about lakes, isn't it? If you're lucky, then some text that has both houses and lakes. But look at this. Isn't it the quintessence of a house next to a lake? Isn't that the property that you guys all wish to be on the other side of becoming startup millionaires? Right? So look at this. Look at this. Right? So anyway, this was a recap of the last time, and I'll end with that. Dog, jumping dog. So when you say jumping dog, it knows action. Look at this. Right? Occasionally it does get wrong. I believe that towards the very end it might. Yeah, this isn't quite jumping. Maybe ready to jump, maybe, but not jumping. So there it is. A path through a forest is a path through a forest. But can you imagine that it understood this picture to be a path through the forest, which looks like a snake?
So are these pictures already loaded in a database?
Yeah, I mean,
and when we query,
yeah.
it matches some vector and that points to.
No. We just did the embedding. If you look at the code, we created a vector index.
We first loaded these pictures
into a vector search index. Okay. We created our own search index, and that is the bit of the code to read. Somewhere in there, I did it. Glob, you see this embeddings, right? We got the embeddings. Okay? The reason is that if you create embeddings, it takes a long time. So there is a pickle file. You can get it. Unsplash, you guys all know what Unsplash is, right? It's a public site from which you can get non-royalty-free images. And so it is just searching through a tiny database of 25,000 images. That is it. So guys, with that being there, let's now come to the project. Any more questions as reviews? This now, I'll go to the project of today. So guys, what will happen is every project you'll get a document like this. Any feedback on reading the document? What are your first thoughts? Guys who are remote are rather quiet. Sanjeev, or I think you were, Sanjeev, or somebody was trying to say something?
No, I was just asking you the question that
Anybody?
so Asif, I was just asking you a question that the notebook that you have, the section number 16, so we are creating a model, right? So in that, so if I'm taking that code to the production, I really need to do the training on by giving them the test and random and sample data to minimize the loss function, or it's already built in the way that it's not required?
No. That is a good question. That is a good question. See, Sanjeev asked a very good question. When you do this all in-house, does it mean that you have to do triplet training? What's the answer to that? Who would like to venture a guess? Yes, no? No? Yes. No. Why no?
Model comes from this.
You download a model. So the answer is a bit more nuanced actually. What happens is that to train a triplet model like this, you need the kind of data sets that you don't have access, so it's hard to create. So somebody takes the initiative of manufacturing the data set to train these models. Somebody then donates or puts together the GPUs needed to train these models. And those GPUs are expensive, right? By the way, one of the privileges that you have in the bootcamp, which you won't have elsewhere, is that we have those GPUs here accessible to you. They're very expensive machines back there, right? Don't hack them, but they're there. Right? Let's just put it this way: that just to run those machines, the power line is 100 ampere power line. Right? If you were to run those machines at home, you would immediately cause a fire, and the fire department would be there. So these are behemoth machines on which these models are trained. In fact, to train these models, sometimes you need as much electricity as is consumed by a small town. Right? So these are horrendously big models.
These are foundational models.
These are foundational models. So you take a foundational model, the process they go through is called pre-training. They're pre-trained. They're pre-trained to understand semantics. But then when you download it, you ask this question, do I need to train it further? If your purpose is served with the pre-trained model, you use it as is. If it doesn't serve your purpose, then you create your triplet data to further train it. The further training of a pre-trained model is called, what is it called? Fine-tuning. You fine-tune it. And if needed, if you need to bring it alignment with human values, if you notice that it's not aligning with your values, then you do some reinforcement learning of preference alignment. Like human preferences are be polite, right? So if every time you ask it for help and it says, I hate you, I hate you, I hate you, why don't you jump off the cliff? Then it's not aligned with human values. Isn't it? So with language models, one of the things you have to worry about is the alignment problem. Does it, the 3 H's that people talk about, Anthropic talks about, for example, is it honest? Is it helpful? And is it harmless? The 3 H. It must align with 3 H's, right? And it must give the kind of better answers that people like. So all of those things here, if you need to do, you do it as needed. Right? Now, in this bootcamp, we will touch at the very end some fine-tuning. In the next bootcamp, it is a lot of fine-tuning and training of the model. This bootcamp largely will use models that exist, foundational models that exist. Right? And that itself will get you completely tired. Right? So, Sanjeev, that hopefully answers your question.
Yes, yeah.
Similar to that, when it comes to the vectors, so the vector is nothing but again decomposing within the tuples vector is the subtuples. Is that how?
No. Once you have trained the model, all you do is you take your corpus of document. For each document, there's one vector. There's no triplet. There's just one vector, and you just maintain a store of those vectors. And when you store those vectors in a bag, that bag is called a vector database. You must have heard vector databases are a fancy term. So one thing you will do in this bootcamp is you won't use an off-the-shelf anything. You won't use Llama Index. You won't use QDrent or any of the established things. I'm trying to teach you concepts foundationally. You will build every piece of the puzzle yourself.
Does that mean you're going to build a model too? No, right?
Model is the only thing you won't build. Yeah. But just in case you have access to a cache of about 15, 16 H100s, then let's build it. Okay? Like any one of you who has a backdoor into NVIDIA, let's talk. So, all right, guys. So there's a bit of a welcome message. TLDR, it's a team. First thing is that it's a team effort. You will succeed if you doesn't matter what your background is. We all are experienced people. We all have something to bring to the table. If you don't know programming, pick somebody who knows, right? If you don't know systems design, pick somebody who knows. If you don't know how to envision a product, pick somebody who knows on that, right? So this is your main chapter, Latent Metropolis of Meanings. Now you know why I gave it such an evocative name. And any feedback on this document, or is it dead obvious what we are trying to do? What you have to do is you have to pick a corpus of documents and shred it and create a search engine. I will give you a few tips, guys. Make your I will give you a starter code to make a lot of this easy. Next time I'll walk you through the starter code, but I want to give you 1 week to try on your own, right? Because if I give you a starter code, it handicaps you. Then you practically see the answer. You won't learn to craft it on your own. Now, but in a way, the starter code is there in the Jupyter notebooks, but you have to chunk the document and so forth. I would suggest you to do this, guys. You guys know Gutenberg, the website Gutenberg. You can take Gutenberg. There are many sites which give you free documents, right? Or pick those free documents. Use any tool, preferably pick plain text so you don't have the burden of converting it to text. If you take PDF, there are many a tool to convert PDFs to text, right? For example, if you are working on Linux, Poplar is a good tool. It's a command line utility. It will convert any PDF into text. There are Python utilities to convert PDF into text, right? Use your favorite tool to convert the PDFs into text. After that, chunk the text, right? And once you have the chunks, those chunks are your input to the encoder. Create a vector.
Chunking part.
Yeah.
So we can speak. I just did a very crude chunk. This character
Yeah,
chunk.
good enough.
We have to go
So-
to semantic chunk. It's okay for libraries that are there in open source.
1 second, guys. You can use libraries in the open source. Use anything, guys. The only thing that you can't do is just download Llama Index, set it up, point your documents to it, and say, I'm done. You are creating your own version of these platforms. The thing is, you will learn only if you build it on your own. That's it. So even the semantic chunking, try to reason. How would you do it? If you can't, then use a tool. So see, here's the thing, guys. How deep you want to go down the rabbit hole, to some extent, is your discretion. Use it as it. Okay, somebody remote was asking a question.
So Asif, let's say I have a document that describes how to troubleshoot laptop, for instance. The document is about 1 MB. So essentially, when I'm doing a search, I need to see all the steps one by one. So I have a document, I will have document ID put into the database, and now I'm going to chunk it into the 1 MB into the 512 bytes into many. So
Yes.
that's what you're saying?
Yes. That is it. That's what I'm saying.
Okay.
That's it. Yeah. So guys, this document, when you read it, in the beginning, it will look a bit dense. If you read it a couple of times, it will become obvious. So you index the chunks. You go. Now, how do you store the chunks? The magic word for that is, I don't know if I mentioned it here, use FAS. FAISS, FAS index. Right. I think I did mention semantic search. Is there in the document? Yeah. So use FAS index. After that, what we'll do is the next stage of this project will be even more fun. We will have the books talk to you. Wouldn't it be lovely if you didn't have to read the book, but you could just ask and say, explain this to me. And the book started talking to you, literally. And you can say, I am a 10-year-old. You are a book on quantum chromodynamics. Still talk to me and answer this question. And the book could, in view of your age, still give you the answer to your question, but explain it in a language that you would understand. Wouldn't that be the fun project? That's your next project. What's that?
I said the Claude.
Yeah, that is it. See, guys, all these commercial tools exist that do it. But do you ever believe that you could do it? You will learn to do it foundationally from the ground up. Yeah. All right, guys. So that is this document. I'll leave you guys with it. Now, here's how it will go. Lunch should be here shortly. Hasn't it come?
Yeah, it's coming.
It's coming. Okay. Yeah. Oh, yeah. I mean, yes, yeah. Lunch is here. That's right. So thank you. Lunch will be here shortly, or is here rather. Have your lunch. After that, there are 2 foundational papers I'll read. You need your full attention because, well, the title of the paper is Attention is All You Need. So bring your attention, full attention. All right?
Wait, so after the lunch,
Yeah, go ahead.
probably you should do the paper reading before lunch.
No, it'll be too hungry. It will take an hour and a half to explain that paper. It's a deep paper. We'll do
I meant for next week,
from next
right?
time.
Because if we are fully stuffed with food and then you go into paper reading in the concept that probably we don't even able to understand, then it becomes difficult.
But you know what? My paper reading might be a good soporific to finally put you into deep sleep. So, after food. So, all right, guys. So there'll be 2 paper readings, guys. Don't go home. These 2 paper readings are very important. We'll cover 2 foundational papers. Attention is all you need. So bring your attention. The second paper is BERT. You must have heard about BERT, Roberta, Dilbert, Distilbert, this, that, right? All of those BERTs starts with the BERT paper. We are going to cover those 2 papers and we are going to cover it very, very carefully. So in this bootcamp, guys, we'll take a 2-legged approach. You will do things and learn, but you'll also learn things straight from the source, not from a textbook, but from the original research papers. Right? And it will be my job to simplify it and make it accessible. I hope the sentence BERT paper looks easy relatively now, right? So we'll cover in the space of this 3 months, we are going to cover at least 3 dozen papers, right? So that's that, guys. All right. So get coding.
What time will you be coming?
Oh, so we'll keep lunch. It is in California, it's about 1 o'clock. Guys, should we take a break and say we'll gather here at 2 o'clock? 1 hour lunch? Let's take an hour lunch.
One question the project. So when you compute, let's say you create a corpus with 64,000 entries.
Yeah.
When we talk about the KNN, you're actually trying to do, let's say, use a dot product. You're doing a dot product across all.
No, you don't need to. That's what FAST does for you. It doesn't do a linear search across millions of documents. So there's a whole field of algorithms called approximate nearest neighbors.
I see. But then without computing a dot product, how do you know that?
Because you have pre-indexed it in such a way.
You put it on phase or when you give it, it doesn't.
It internally does it. So what happens is, imagine, right, that it makes buckets. Let's say that school is a natural quantization, right? Very small children, kindergarten, right? Then first grade, 10th, 12th grade. So at the end of it, if you're searching for somebody, and I tell you that the person is a 10th grader, you're not comparing only against the 10th graders.
So it's an index of index.
Yes, it's index.
Something like a binary.
It's sort of like that. It's quantization, and that is right.
Okay.
And the approximate nearest neighbor algorithms have been maturing both in quality and in performance. They run at blazing speed. I'll give you a thing. My daughter works at a company where she manages images, social media images. And they maintain, I mean, I can't give the exact figure, but they talk in terms of hundreds of billions of images, and you search for it in blink of an eye, just like that. Right? And by the way, these technologies that you are learning about, believe me, it is being massively used everywhere. These are big use cases. All right, with that, I'll call it a lunchtime. I'll see you guys all at 2 p.m. California time.